trigonometric application basis. So we're going to do some examples how to apply trigonometry to everyday problems. So the first thing we have to know is angle, elevation, angle, depression. And this visual here kind of helps, but the general idea is it has to come from a horizontal line. So you draw like a horizontal line. Here's my horizontal line. A line above that would be the angle of elevation. The line that goes below that is an angle of depression. So that's the general idea. So you have a horizontal line, below that angle of depression. You can see this right here. Like here's the lifeguard looking ahead, and then angle below that angle of depression. And then we have the swimmer here, right, straight ahead. There's my angle. There's my horizontal. Angle above that is elevation. Now from here, actually, if these two lines are parallel, then these are equal. They're all interior. So if you have a picture like this, then angle of depression, angle of elevation are the exact same angle. But the way you generally draw is draw a horizontal line, angle above it, angle elevation, angle below that, angle depression. So let's use that to solve more problems. A ramp is unloading a moving truck and has an angle elevation of 32 degrees. So angle elevation right there. So if I was like here's my horizontal line, that's my angle elevation. So we're just gonna draw that there. So boom, I'll draw it this way because that's easier for me. 32 degrees. If the top of the ramp is 4 feet above the ground, so the top of the ramp, this guy right here, that's 4 feet. So we're talking about the height. So if I draw a line from here, this is 4 feet. That's what they're talking about. Estimate the length of the ramp. So how long is the ramp? So remember, the ramp is, in this case, is this part right there. So the ramp should be my hypotenuse. So I'm looking for this guy. So there we go. So again, right, I had to set it up. I was like, okay, I have the picture here to help me, but angle elevation, so horizontal line above. It said from the top of the ramp is 4 feet above the ground. So they're talking about the height here. So this guy should be a right angle. And they want the actual length of the ramp, which will be this one. In this case, that's what we're talking about. So how do we solve it? Same way we solved it before. SOH-CAH-TOA. So helpful. Man, I love SOH-CAH-TOA. Right? So look at here. We're going to list the sides. So there's my angle. This guy is opposite. This guy here's my right angle right here. So this is hypotenuse. That makes this adjacent. What do we have? We have opposite and we're looking for hypotenuse. So O and H. So we're doing sine. So we're going to do sine of my angle, 32, equals, again, O goes on top, so 4 over x. And then we're going to cross multiply. So put this over 1. X sine of 32 equals 4. Now, I got to solve for x. I get rid of that sine of 32. So we're going to divide both sides by a sine of 32. These cancel and I get x equals 4 over sine of 32. Bring out a calculator. 4 divided by sine of 32, which is 7.5. We'll round it to. So roughly, approximately 7.5. And what is this, feet? Yep, feet. So I would say, right, the ramp is about 7.5 feet. That's how long the ramp is. So that's our first example, right? Again, all we're going to do is draw a picture and then kind of solve like normal. Figure out the sides, list out what the sides are based on the angle you have, SOH-CAH-TOA to figure out which trig function I'm going to use, and then solve it like normal. So let's do another one. Let's do one that's a little more involved. Nathan is standing in a meadow exactly 185 feet from the base of El Capitan Mountain. At 11 a.m., he observes Emily climbing up the wall and determines that the angle of sight is up to Emily is about 10 degrees. So they want to solve first. If Nathan's eyes are about 6 feet from the ground, how high is Emily at 11? So we need to draw a triangle. So here's Nathan. All right, he's looking with his eyes. And then here's Emily somewhere. She's climbing this thing. Now he's seeing up to Emily's height, and then he's going straight across. And what they tell us? That he's about 185 feet from the base of El Capitan. So from here to here is about 185. And he's also 6 feet from the ground. So he is 6 feet. So that makes this side from here to here also 6 feet, not drawing a scale. and the side of Emily is 10 degrees. So this is 10 degrees. We just want to figure out how high Emily is, so we're trying to figure out this. So we have a triangle, right? Here's our little right triangle. This is x, this is 10, this is also 185. SOH-CAH-TOA. Right, the way we can solve it, you gotta figure out which one we're using. Here's my angle. So this is opposite, and this is adjacent, right? Because my right angle is right here, so it's hypotenuse. So we're using TOA. So let's solve it, right? Set up the equation. Tan of 10 degrees equals opposite on top, right? O is on top, over 185. Right, so I'm going to use this to solve, and don't forget, once you solve this, you're trying to figure out her height from the ground, so we're going to add the 6 feet after. So let's cross multiply. I get x equals tan of 10 degrees times 185. And we're going to put that into our calculator. If we do that, we get 32.6. If I round it, 32.6. Again, that's not the final answer. That's how tall this is. This is 32.6. But we have to add the 6 feet because we don't figure out her height from the ground. So plus 6, and we get about 38.6 feet. So that's how tall Emily is right now. Okay, 38.6 feet. At 11:30, Emily has climbed some more, and Nathan's angle of sight is now 25 degrees. How far has Emily climbed the past 30 minutes? Ooh. So now, let's draw another picture here. Emily's even higher up. My picture's not drawn on scale. So now he sees that it's 25 degrees. This is still 185. And it's been, only difference, it's been 30 minutes. So we're still trying to figure out what x is here. It's still 6. So we're trying to find x again, but now it's a higher angle. So let's do the same thing. Oh, we already know it's going to be tan, so let's do that, right? Tan of 25 equals x over 185. Let's cross multiply. Right, it's tan because it's the exact same ratios. That's why it's 10 still. 185, tan of 25. Put that into our calculator. So I'm going to get 185 times 10 of 25. And we get 82.3, let's say. So x is about 82.3. Now that's not the answer. This is 82.3. We're trying to figure out how much higher she climbed. So here's the thing. I could add the 6 and then subtract the 2, but we know a couple of things. We know she started actually at 32.6, not including his height. And now we're at 82.3, not including his height. So all we gotta do is subtract those two to figure out how much higher the person is. So we're gonna do 82.3 minus 32.6, right? Because that's how they were, not including our height. That's how high they climbed. And we get 49.7 feet. So she's climbed 49.7 feet in that time. So she's picking it up. Okay, last question real quick. If Emily climbs 32 feet higher in 10 more minutes, what angle will Nathan have to look in order to see her? So she's going 32 feet higher. Now again, right now, we have her at 82.3, not including our height there. This part right here, 82.3, like from his eyesight. So we're going to add 32 to that. And we're going to get it, if I draw another picture, right, we're going to get a thing that's like that. 32 to that's going to be 114.3. So that's how high she is on her picture now. She's about 114.3. We're trying to figure out his eyesight. This is still 185, but we don't know what this is. So like that. Alright, so that's what's going on here. Like, again, I don't need to add the base because we're adding it to the top there. So all of this from here to here is 114. Like, right, there's still a 6 we're not including. So that part there, we just have to solve this triangle right there. That's all we're going to do. So what trig function we use? Well, same way we've been using, right? This is opposite. This is adjacent. We're just going to set up the equation. So tan of x equals 114.3 over 185. Right? Opposite always goes on top. And then we want to get rid of the tan function here. And the way we do that is by doing tan inverse. So we're going to do tan inverse of both sides to find the angle. We put that in our calculator, and then we get our answer. What angle he has to look up to find her. So we're going to do tan inverse of 114.3 25.3 divided by 185. And you get 31.7. So that's the angle he has to use to look up to find Emily. And that's the lesson.